Now, we are going to look at finding equations of parallel lines. That's what we are going to look at now. How do we find the equation when we have parallel lines? And our first activity is going to be this. We are going to plot the following lines on the same graph. I have that is my first line and that is my second line. But I don't know whether we have to do it together or you can first do it as an individual. What do you think? Let me know through the chat. Should we first do it together? You say together, individual. Choose alone. Maria Martha said alone. Okay. People are saying together. Okay. Members are suggesting we first do it together. Yeah, okay. We are going to do it together. Now, what is going to happen? One, we are going to plot the lines, but for you to plot your ends as I also plot mine. Now, I have my graph. I have my graph. This is my graph. This is my graph that I'm going to plot on, and the 2 points I have, these are my points that I'm going to plot on this graph. So I'm going to write them. Let me put them here. These are my 2 points. Now we say that when we are plotting any lines, the first thing we do, we draw our table. So we are going to draw our simple table. And in our table, we are going to have coordinates. We shall have our x and y. Now, our first equation we have is y is equal to 2x minus 2. And therefore, we say that for this particular thing or for any line, it is always a good practice to have some negatives and some positives. So allow me to have some negatives and some positives. So it is up to you to choose which negatives. So allow me, I can say -2, -1, 0, 1, and then the 2. Then after getting your points, remember these x values are not given to you. So it is up to you to come up with what you want. You can start from -3 or to 4. It is up to you. Then after obtaining those values, we substitute in. So I'll have y. When I put in -2, I'll have 2 times -2 minus 2. This will give me -4 minus 2, which will give me -6. So members here, we shall put -6. Then I continue, but raise up your hand and you take us through. Someone can raise up the hand and take us through -1 quickly. Okay. Anyone who wants to take us through? Okay, yes, Teddy, unmute. Elena, you are going to do another and you can as well unmute. Hanifa also unmute. We start with Teddy, then Hanifa, then Elena. Yes, Teddy.
X is equal to 2x minus 1.
Okay.
X is equal to 2 times 1.
But it is -1.
-1 minus 2. -2.
Okay, which will give us -4. Okay, that is good. Yes, Elena. That was Elena. Hanifa. So you are doing the one for 0. So we shall have 2x minus 2. Yes, Hanifa, go on.
2 times 0.
2 times
0 minus 2.
Okay.
0 minus 2.
Okay.
Which will give me.
Okay, which is -2. Okay. Thank you, Jordan and Trinity.
I'm doing the one for 1.
Okay.
we say 2 times 1
2 times 1.
minus 2.
Okay.
2 times 1 we get 2 minus 2 and then we get 0.
Okay, good. Then the last one, is it treating that one? Yes,
Yeah.
go on.
It is y equals to 2 times 2 minus 2.
Okay, 2 times 2 minus 2, which will give us
4 minus 2.
which gives us
4 minus 2.
what is the answer now?
2. Positive 2.
Okay, very good. So members, here we shall put our 0 and 2. Then we are going to go on and extract our coordinates. So we are going to plot coordinates. Here we shall have -2, -6. Here we shall have -1, -4. We shall have 0 and -2. Then we are going to have 1 and 0. And then lastly, we shall have 2 and 2. So those are the coordinates we are going to plot. Now, allow me to come on my graph, as also you go to your graph. And on my graph, I'm going to draw my straight line. Me, I'm using, so for you, use your pen. Then I'm going to come here and also I draw my line like that. Then after drawing, I'm going to come and I label my line that I've drawn. And that line, I'll put here that this is 0, 1, 2, 3, this is 4, 5, and then I label that this is the x-axis. Then I'll come here and I say this is -1, -2, -3, -4. Then I go along the y-axis. I say this is 1, this is 2, this is 3, this is 4, and I'll label that this is my y-axis. Similarly, I do the same. I say this is -1, -2, -3, -4, -5, and then the last point down here is -6. Now I start plotting. -2, -6 is a point down here. I may first leave that point. I go to -1, -4. It is a point here. I go to 0, -2 is a point here. I go to 1, 0 is a point here. I go to 2, 2 is a point there. Now, after drawing my points, I'm going to get my good ruler, and then I join those points. So you are going to join the points and see how the line looks like. Now, when I join mine, this is what I'm getting. I'm getting something like that. Yeah. So allow me to label it that this is my line. This is my line, y is equal to 2x minus 2. Now, after drawing that line, we are going to draw our second line, y is equal to 2x plus 2. So members, I'm going to still draw my table. Now, in my table, still I'll have my x, I'll have my y. So I'll still say -2, -1, 0, 1, and 2. Then I'll come in this equation, I substitute in my values. Okay. So I'll come and then I put my values. So when you substitute in -2, so you'll say 2 times -2 plus 2, which will give us -4 plus 2, and our answer will be -2. So anyone putting up the hand, you are going to just be telling us the answer. Calculate, and then you tell us the answer. Yes, treat. Oh, Teddy? Oh, J? Yes?
For -1, 0.
Okay, for -1, you have 0. Good. Emanuela?
For 0, we have 2.
You have 2. Okay. You have 2. Okay. So there we shall put a 2. Then Zara. Oh. Okay. Daniela K. Or Zara?
Teacher, for 1, I have 4.
For 1,
Even
you
me.
have 4. Then for 2?
It is
Yes.
8.
You have 8. Okay, good. So after that, we shall come on and have our values extracted. So this will be -2, -2, -1, 0, 0, 2, 1, 4. Oh, Zara, here we are going. I think this is not 8. I'm saying it
36.
is 6, eh?
Yeah.
Okay. So here, this is supposed to be 6. Yeah. Okay, then we shall plot -2, -2. So it is a point here. Allow me to use, I think, another color. Oh, wait, let me choose another color. Okay, let me use black. So it's going to be here. Then -1, 0 is a point there. Then 0, 2 is a point here. Then 1, 4 is a point here. Then the rest of the points, I can ignore them because those values will be able to give us the right thing. Now, afterwards, allow me also to use black when I'm drawing that line. I'm going now to draw that line. So I'll come, I draw like that. Yeah. So that is my line. And then after, I'm going to label that line, that this line here is the line y is equal to 2x plus 2. Now, the questions are coming. What do you notice about those two lines? Raise up the hand and you tell us, what do you notice about those two lines? Okay. Elena?
So what I noticed that those two lines are parallel.
They are parallel. What are you basing on to say they are parallel?
According to what I see, they don't meet at any point.
They do not meet at any point. Very good. Thank you, Elena. Yes, Teddy. Another thing you are noticing?
They are parallel.
They are parallel. Okay, good. Now, I want you to give me, in terms of gradient, what do you notice about those lines? You can put in the chat even your answer. What do you notice about their gradients for those two lines? Teddy, you want to give us an answer? What do you notice about their gradients? Positive gradient? Okay, that is 1. I want someone, what do you notice about their gradients? Okay. Semakola said they have the same gradient. Okay. They have the same gradient. J, they have the same. Very good. Both have the same gradient. Okay, positive. Now, positive may not necessarily define to show, yes, they have similar gradients. Very good. Now, can someone raise up the hand and you tell us what you think parallel lines, or what you think parallel lines have, or how you can describe something that is parallel. What you are going to describe in your book. What do you think is special about treat? Oh, treat me. You are not unmuting. Okay, yes, Zara.
Teacher, according to me, parallel lines are lines which will never meet. No matter how long they are, they will never meet because they are parallel. The thing is supposed to be that they never meet.
Okay, thank you. Yes, what about treating?
According to me, parallel lines are lines that do not meet at any angle.
Lines that do not meet at any angle. Okay. 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 Very good. Then Martha.
Sure. Parallel lines are lines that do not cross the path of one another, or even if they don't meet, even though they are being extended indefinitely.
Okay. Okay. Thank you, Martha. Maria, Martha.
One common characteristic they have is that they keep the same distance apart.
Okay, same distance apart. Very good. Yes. Now, members, what you are describing is what we are going to look at. That's what we call parallel lines. But when we reach equations, like Semakula and other friends told us that one thing that is going to come out very well is that for the two lines to be parallel, one, you have said that they can never meet. Secondly, they would always have the same gradient. So for you, the moment you see the word that these lines are parallel, what has to come at the behind your head that these lines have the same gradient. So for anything that is parallel, their gradient is going to be the same. So always for you look out, do those lines have the same gradient? Hope members that is very clear. They can never meet, the distance apart them is the same, and they'll never, they'll have always the same gradient. I want you to look at those lines through the chart. Do you think those lines have the same gradient? If yes, which of those lines do you feel they are parallel? Okay. Treating. Do you feel these lines are parallel? Yes, sir. Emmanuel is saying yes. So when you look at our lines here, it is showing you that the lines are parallel. However, for you to prove that those lines are parallel, one thing you have to first look out for, even if you look at them when they are facing the same direction, first check out their gradient. So you first check out whether their gradient is the same. Once you find out that they are the same, then it means that those lines are parallel. So that is what you are going to check. I will send you this work, and then you check out and find out whether actually all of them have the same gradient. Now, let me ask in the chat, the question is, are these lines parallel? Put your answer in the chat, yes, no. Put in the chat, yes, no. Okay, looking through the chat, people are saying yes, they are parallel. Same gradient. Now, some of you have answered in a very good way. You have said yes, they are parallel because they have the same gradient. And even you have gone further to say that the gradient is 3. Very good. Very good. We can continue. So when you draw those lines, they will look like that. And therefore, yes, both have the same gradient, and therefore we can say that they are parallel. Are these lines parallel? Members, put your answer in the chat. Are these lines parallel? Zara said no. Put the reason. Put the reason. Because they have different gradients. The gradient is not the same. Very good. Because when you look at the first line, the gradient is -2. The second line is -3. Very good. So when you plot these lines, they will be like that, meaning that those lines are going to be meeting. So they are not parallel. Very good. Okay. Now, I want you to put in the chat to create your own equation. Which is going to, I want you to create your own equation, and that equation you are going to create, I want it to be parallel to this line have put here. Put it in the chat. I want you to create your own equation, which is parallel to this line. Members, you people are very wise. This is brilliant. I'm seeing only correct answers in the chat. Yes, yes, that is very good. That is very good. So one thing you have to do, members, the only thing you have to do is to make sure that the gradient is 4. So for you, whatever equation you come up with, it will be correct. As long as the gradient is 4, it doesn't matter the y-intercept. It doesn't matter. It does not matter. Yes. I have put for you another line. Y is equal to -5x. So here, please feel free, as long as the gradient is the same. So those who have given me 4x minus 3, 4x minus 1, 4x plus 100, 4x plus anything, as long as, even if you have just given me 4x, as long as the gradient is 4, that is what makes it parallel. I've given you another line. Oh, very good. Looking through the chat, I'm seeing that is very correct. As long as the grade, oh, who's giving 5x now? Who's giving -7? Emanuela, Frida, Peace. Yes, we have said parallel lines, they must have the same gradient. So as long as for you the number you accompany with x doesn't match, then yes. Infinix, no. Elena, yes. Zuli, yes. Noel Maria, you are forgetting the X. Jordan, yes. Shuma, yes. Tiger, yes. So those answers are correct. So for you, what you have to ensure is that the equation you are creating has -5x. So for you, just say y is -5x plus 2, or plus something, or minus 4, or what. As long as you have -5 as your gradient for that equation you are creating, then that equation will always be parallel. Jeremy, that is good. Teddy, yeah. Maria Martha, yes. Bridget, yes. Those answers are very fine. Husna, yes. Tritin, yes. Yeah, at least those answers are very correct. Members, are we on the same page? Are we on the same page? Let me know through the chat. Let me know through the chat. Are we all on the same page? Very good. Now, let me ask you, can you write something in your book about parallel lines? Write something small you have understood about parallel lines. Write it in your book. Okay, people have finished right. Very good. Now, we are going to dive into and do some number. Okay. Now we have here, they are telling us that our heading is finding equations of parallel lines. Okay, what do we do? Find a line parallel to 2x minus 1 that passes through 0, 3. Now, for the past number or for the other numbers that we were doing, I showed you, you were just creating an equation and you were using any intercept that came into your mind. But for this particular one, we have to be specific because we have to obtain the intercept that goes through, much as you know the gradient that is going to be parallel to this line, but we must be able to find out that particular line. So what do we do? The first thing now you know about parallel lines is that one, parallel lines have the same gradient. So the line they have given us is 2x minus 1. And members, through the chart, what is the gradient for this line they have given us? What is the gradient for this line they have given us? Okay, Isaac, 2, Zara, 2, Martha, 2, Ethan, 2. Very good. So we are going to say that our gradient here is 2. Now we are going to ask ourselves, we want to find another line which is parallel to this one, but that line must be able to go through 0 and 3. So what are we going to do? We are going to say y is equal to mx plus c. Then we shall say y is equal to the gradient we know already, 2x plus c. But they have given us a point 0, 3. So we shall come and I say our point is 0, 3. So this is your x and this is your y. So what do? You substitute in for your x and we substitute in for your y. So I'll come and I say my y is 3 is equal to 2 times 0 plus c, which is going to be 3 is equal to 0 plus c, and therefore our 3 is equal to c. Now, after getting this, you go back and write your line. So I'll come back and I say, my line is 2x plus c, but my c I have obtained 3. So I'll say my y is going to be 2x plus 3. And when you look at this line and the line they have given us, you notice that they have the same gradient. It is the intercept that changes. But since the gradient is the same, then it means that those lines are parallel. Members, is that fine? Let me know through the chat. Is it okay? Okay, members are saying very okay. Okay, fine. Okay, let us write it. And then we try another number. Okay, some people have finished. Okay, 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 but I'm seeing a hand up. Maybe Goret has something. Yes, Goret.
Excuse me, sir.
Yes, please. Yes, Goret. Yes, correct. Okay, I think Colette, your background is not. Okay, I think members have finished. Okay, so when you draw that line, it will look like that. And then the one that we are going to draw, or the one we have obtained, it will look like that. And surely when you look at those two lines, they are going to be parallel. Okay, I have another one. That is another one. Can we have a try, everyone? So we are trying. Okay, everyone is trying. Yeah, let me hope. Okay, who wants to take us through? Who wants to take us through? Mhm. Yeah, I want to say, okay. Nora, I know Ted and Elena have said something. Nora?
Okay, so we are going to find a line parallel to y is equals to 3x plus 2 and also passes through the coordinate 1, 0. So we already have our gradient, which is 3.
Okay.
So we write our equation as y is equals to 3x plus c. Now we are going to substitute our coordinates into this equation. We'll have 0 is equals to 3 times 1, which is the x plus c. Then we'll have 0 equals to 3 plus c. So we'll subtract 3 on each side, which will give us 0 minus 3 is equals to 3 minus 3 plus c. Then we'll have 0 minus 3 is equals to c, giving us negative 3 is equals to c. And then we make the equation, sorry, the line as y is equals to 3x plus negative 3, which gives us y is equals to 3x minus 3.
Wow, thank you, Nora. That is correct. Yes, so that's what I expected. And when you draw those lines, they will always look like that. So that's what you had to do. And that is very correct. Thank you, Nora. So, yeah. So we are going to end at this point. I'll give you more other numbers maybe to do on your own at a later time. I want to thank you so much for attending. In case you have any questions, feel free to share them such that I can be able to respond to them. Otherwise, I want to thank you so much. Thank you so much for attending, and most importantly, for sacrificing your time. May you please, after the lesson, always keep asking yourself the why. Why do you think you have kept yourself on a call up this time, yet there are other people who have dropped off? So keep asking yourself why, and why.